All right. How's everyone doing? I guess I shouldn't say everyone. It's interesting. All right, sign-in sheets coming around. Hopefully it's just the cold weather that kept everyone away today. But that's one of the drawbacks to doing these videos is that students will say, I'll watch the video and not go to class. But remember, I keep track of absences, so you get 4. That's it. Parking? Is it worse today than it was on Tuesday? Yeah? Okay. Well, we'll let people kind of show up, but we're going to get started. So we left off, there was no homework, right? Other than you needed to get the book so that you could do the homework out of here tonight. So that's the book, right? Hopefully you're able to get that. What I'm going to do is I'm going to be working problems straight out of the book. My goal is to first do this problem, then I'm going to give you a problem to do, and then that's going to take at least half an hour to 45 minutes to just do this one thing, and then we're going to go ahead and move on to a couple other topics. I don't think we're going to get to 5.1 today, so we're supposed to do 5.1 today, but I don't want to rush through this, so we'll be a little behind. It's okay. Were there any questions over the syllabus or anything else from last class? Questions about how the course works? We're good? Okay. So we are going to work through this problem. We're asked to solve this, well, what is this called? We have an equation. We have variables x, 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 all raised to the first power. So it's a linear equation. Therefore, we can follow the 6 steps that we did last class, right? So I'm going to be solving this linear equation. The first step to solve a linear equation, if you recall, is to remove all grouping symbols. And we have a good pile of grouping symbols here, don't we? We have braces right there. So we work everything inside that braces first. But within the braces, there's a set of brackets. So we're going to go and do everything in there first. But within the brackets, there's a set of parentheses. So we have to do everything inside the parentheses first. So we've got to work from the blue out to the yellow, out to the green, and then try and solve. Now, we look at what's inside the blue parentheses there, and we ask ourselves, is there anything we can do? Can we combine the x and the -3 together? They're not like terms, so we can't do anything. Anyone else need to sign in? Okay. So we cannot combine the x minus 3, so what we're going to do is try and remove those parentheses. To remove them, we have to multiply by whatever's out in front of the parentheses. So what is in front of the parentheses? A -1, right? That 4 has nothing to do with it. So what I'm going to do is I'm going to put a 1 next to that negative. Right? That's actually, anytime we see a negative by itself, it's a -1. So we will take that -1 and we will distribute that -1 through the blue parentheses. So I'm going to multiply -1 times x, and then I'm going to multiply -1 times -3. Now, because we're not worried about wasting paper, and we love to write, I'm going to write the entire thing down again with just that distribution changed. All right? We're not worried about paper, right? Have you seen all the trees out there? Have you looked out there? Look at all those trees. We're not, I think it's a big conspiracy. There's not enough trees. Okay, so what do I get? The 4 is still there, but now what? -1x. Now, do I have to put the 1? No. Is it wrong to put the 1? No. So whichever you prefer. I'm just going to put -x. And then +3, so +3, good. Now the parentheses are gone, right? So what's the next symbol I need to put here? Bracket, and then the brace, right? Equals 11, pardon me? Equals 11, is that what? Did you figure out your situation? You're good? Okay. All right, now, same thing, I'm gonna be working my way, inside, I go to the brackets. Is there anything inside the brackets that I can put together? Yes, I can put the 4 and the 3 together, right? Add 4 plus 3 is 7. Again, I'm trying to get better at math, so I'm really working on my handwriting. I'm working on writing every step logically one to the next, including the entire problem every step I go. Not 4. What should it be? 7 minus x. Now, I could put, if I didn't want to put 7 minus x, I could have put negative x plus 7. So it could be that, or it could be this underneath it. Either one. I'm going to prefer to just go with that one. I close off the bracket. I close off the brace. Equals 11. So you might be saying to yourself, wow, that's like a lot of writing and stuff. And here's the thing. The benefit for you is if you do something like this on a test, right, and you get the wrong answer, and I can go back and I can clearly see your work. Like what if right here on this step, I would have written 8 here instead. I think it would be pretty obvious, at least as an instructor, to be able to look at this and say, 4 plus 3, I don't know why, but they put 8. And that's the only mistake in the entire problem. If you're doing all this math in your head and trying to do it, and it's wrong, and I can't tell what you did wrong, it's all wrong. So the more I see, the better for you. 7. All right. Now we've done everything inside that bracket, but I want to get rid of the brackets, right? I want to get rid of these. So I'm going to come in here and try and distribute whatever's in front of it. And what's in front of it? Negative 1 again. So I have that negative 1 sitting in front. This 4x and this negative 6 don't even matter. So let's distribute that negative 1 through, and that'll be our next line. So what do I get when I distribute that negative 1 through? Negative 7, so no more bracket, right? Just negative 7 plus 1x, or just plus x. No more bracket, so I can go and now just put the brace there. Equals 11. How is that? Can I combine anything inside the braces together? Yes, I can put negative 6 minus 7 together because they're like terms, and then I can put a positive 4x plus another x together. Combine those. So that'll be my next line. 5x minus 2 brace. Okay, what should I put in there? 5x minus 13, or you could put negative 13 plus 5x. Either way, it'll work. So I'll put 5x minus 13 because earlier I put the x second and the number first. So in this one, I'll just show you that it can be the other way around too. You can put the x first, then the number. There's not one way that's more right than the other. Okay, they're both the same. And then equals 11. And now I want to get rid of the brace. So I distribute the negative 2, right? The whole number through there. Negative 2 through. We're getting close here. 5x minus 10x. Is that right? We have 5x, negative 2 times 5 is negative 10, but then you have to bring the x along. And then negative times negative here would be positive and 26. So plus 26 equals 11. Okay, congratulations. We have done the first step of solving a linear equation. We have removed all grouping symbols. The second step is to clear fractions and decimals, which we don't have, right? We don't have fractions or decimals. So the second step's good to go. What's the third step? Combine like terms on each side of the equation. So on the left side, I can do a little more work because I have 5x minus 10x. 26 I can't touch. The 11 is by itself. So just put the 5 minus 10x together, and you get, what? Negative 5x plus 26 equals 11. So now I've combined like terms on both sides, so step 3 is done. Step 4 is to isolate the variable term. That means I want to get the variable term here, negative 5x. I want to get it by itself, so I need to get rid of this 26 by basically taking it to the other side. That's one way to say it, or to eliminate it by adding the opposite of it, or subtracting 26, right? So I'm going to subtract 26 from both sides. I'm going to do that subtraction vertically, like we talked about last class. And I'll put the line there. I know a lot of you said you didn't use the line, and I normally don't either, but I'm going to this semester. What happens on the left side? Yeah, they cancel and you just get negative 5x, right? So negative 5x is here. We still have the equal sign between them. And then what's 11 take away 26? Negative 15. Okay, we have isolated the variable term. So the fifth step from last class is to solve for the variable x. So I need to come in here, look at x. It's being multiplied by negative 5. To undo that, I divide by negative 5. Exactly what's out there is what I'm going to divide by. So I'm going to take my negative 5x equals negative 15. Divide both sides by negative 5. The negative 5 over negative 5 is a 1. So it just becomes 1x, which is x. Negative 15 divided by negative 5 is positive 3. So the answer is 3. Well, we think it is. Step 6 would be to check it. And how do we check it? You've got to go all the way back up to the top and replace all of your x's with 3's and see if it turns out to be true. Do y'all want to do that? Yeah, you want to, just to see how ugly it is? Okay. See, the good news is, like on a test, you can always check your answer to see if you got it right by just doing this step. The bad news is that it's a little tedious, right? It's kind of a pain in the ass to do it. So I'm going to do it, but I'm going to kind of squeeze it in up here. Okay, what I'm going to do is rewrite the problem. Everywhere I see an x, I'm going to replace it with what? 3. So here's, what is that operation between those? Multiplication, right? So 5 times 3 minus 2, brace, negative 6 plus 4, and then that's times 3. And then minus bracket 4. It was just minus parentheses. The x was a 3 minus 3, close, 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 equals 11. So that's just replacing all my x's with 3's. So let me just work these out here. What's 5 times 3 up here in the front? 15. I'm going to need more room. I know you can't do that on your paper, sorry. But what else? I'm just going to say minus 2, minus 6, plus 12, minus, in brackets 4, minus, what's 3 minus 3 in that parentheses? Nothing, right? 0. So 4 minus nothing equals 11. What's 4 minus nothing? 4. So what's negative 6 plus 12 minus 4? Negative 6 plus 12 minus 4. What's negative 6 plus 12? 6, and then take away 4? 2, right? So 6 minus 4 is 2. So what we have is 15, take away 2, and then in the braces came out to be a 2. What's that operation? Right here. Multiplication. And we do that before subtraction. So 2 times 2, 4. So 15 minus 4 is 11, isn't it? So it checks. All right, your turn. So I'm going to give you one to do now, all right? Watching me is always easy, right? Because I shouldn't make mistakes. I do. It's not. I'm a human being. But you know what I'm going to do is I'm going to put the problem up there. I want you to work it out. When you get the answer, I want you to raise your hand, and you can talk to each other. I encourage you to, like, you know, help each other out. What I want to see is, you know, like where everyone is, because I could sit up here like this, and to me, everyone's like, okay, yeah, got it. But until I actually see you do one yourself, I don't know where your weaknesses are. I don't know where your strengths are. So go around and kind of see where you're at. All right, 2x minus 3 brace negative 2 plus 3x minus bracket 5 minus parenthesis x plus 1, close parenthesis, close bracket, close brace, equals 38. All right, there you go. I'm going to pause this video. All right, so the correct answer was negative 2, right? All right, let me get back to this. Was that the one I put on the board? No, that's not the one. Okay, well, you know what I'm going to do is I want to do the one that I put on the board there for people who had finished the 9x one over there. So 9x plus 3, what is that, x minus 1 equals negative 4, x plus 8, and then plus 16. Okay? Can you mirrorcast like to your TV from your iPhone? I didn't think so. Yeah, I didn't think so. I'm just giving you a hard time.
Actually, I can't control my AT&T so my phone works now.
Oh, yeah, like change channel and stuff? Yeah. Okay. All right. we won't start an iPhone Android debate in here today. That's right. You're right. Well, I can too, but it requires stepping on it apparently. All right, so here's the problem. Again, it's a linear equation, right? It's a linear equation. We have our x's are raised to the first power. This one actually is not as bad as far as parentheses and brackets and stuff. All we have to do is get rid of these two sets right here. Now, I'm going to work a little faster through this. You know, still go through the steps, but I'm not going to be as methodical about it. First step, remove grouping symbols. So I'm going to distribute a positive 3 through the first parentheses and distribute a negative 4 through the second parentheses. And do that all in one step here. So what I'll have is the 9x that was sitting out front, and 3, positive 3 times x, that first multiplication is plus 3x. And then 3 times negative 1 is negative 3. No more parentheses. They're gone. Questions? Equals, the second multiplication is that negative 4 to the x, which becomes a negative 4x. Negative 4 times the positive 8, negative times negative is positive. No, negative times negative is positive, but that's a negative times a positive, so that's negative. Sorry, I'm not trying to confuse you, just having a little bit of a blanking here. What else? Plus 16x. Okay, so we have removed grouping symbols. Step 1 is done. Step 2, fractions and decimals. Don't have it. Step 3, combine like terms. I haven't done it. Here we go. On the left side, what can I put together? 9x and 3x is 12x. So 12x minus 3 is what I can put on the left side. On the right side, I can put together negative 4x plus the 16x, and that gives me 12x. And I still have the minus 32. So now I have collected all like terms on both sides of the equation. The next step is to isolate the variable term. However, in this problem, my variable term appears on both sides. So my x's are on both sides of the equation. So whenever that happens, I have to choose which side to leave my x on. And you have the freedom either side. So I'm going to choose the left side. And that means that I need to get this 12x and somehow get rid of it over here. So how can I get rid of the 12x on the right side? Subtract 12x. Now, I had a student in my other class that asked a very good question. Why don't I divide by 12 right now? Or divide by 12 or 12x? Well, here's the reason why. You only come through and divide both sides after you have x isolated, after it's by itself. See, right now, if you try and divide by 12, you've got to divide everything by 12, all of them. And then you're going to create fractions, and it's going to be a mess. Not only that, if I divide by 12, right, if I divide that by 12, I still have what there? X. So I haven't even got rid of the x. It's still there. So that's why you wouldn't do that. So I'm going to subtract instead. I will subtract on this side 12x. Subtract whatever you do to one side, you have to do the other, right? Vertical subtraction. And let's just do that step and see what happens. They cancel on both sides, don't they? And so the only thing left on the left side is negative 3. The only thing on the right side is negative 32. At this point, we can stop. Because what we're saying is that to solve this equation, to make this equation true, what has to happen is that negative 3 has to be equal to negative 32. And that's just not true, right? Negative 3 is not negative 32. So since these are not equal, and that statement makes no sense, what we determine is that there is no solution to this equation. In other words, there is no x that we could ever plug in. There's no number that you will ever be able to check in there that will work. The question is, how do we say no solution? Well, the two acceptable ways on a test or a quiz are to just say no solution, or you can write this symbol. It's a 0 with a line through it, kind of a slanted line. This stands for the empty set. Think of a set as like a basket, okay? If we're working out a problem and we get the answers 3, x is 3, then inside that basket is the number 3, right? The set contains 3. What we're saying is that the set of answers for this is empty. That's different than saying 0. If I say 0, then I'm saying 0 is an answer, right? You plug 0 in, it should work. Try it. Plug 0 in, it's not going to work. So the way that we say no answer is that symbol, empty set. Yes? Mm-hmm. You could add 3 to both sides. If you would have maybe in the step before added 3 simultaneously, then you would have had 0 equals 29, right? Or negative 29, which I think you said over here. And it still doesn't, it's still not true, right? So you would get a different sort of equation here, but it would still not make sense. Okay? Questions? So I wanted you to see this kind of special type of equation, the types that don't have answers. And that leads us to the next type, which is this one here. So I'll give you a second to jot this one down. All right. Is this a linear equation? Yep. Got our equal sign. We've got our x raised to the first power. So first step is to remove grouping symbols. Now, do you see we have a fraction out front? Okay. Up to this point, we haven't had to deal with fractions, but, you know, good news. We get to play with fractions now. So I'm going to remove the parentheses right here by distributing a 1/3 through the parentheses to both terms. And then over on the other side, the parentheses around the x plus 2, to get rid of that, I need to distribute a what through? -1 through, right? Remember, that's a -1 right there in front. So I'll distribute that. All right, let's talk about that first multiplication. I'll highlight it in blue. You're going to take the 1/3 and you're going to multiply it times 3x. Now, everyone here is either really comfortable with fractions or doesn't like them or forgot how to do it. So I'm going to take a moment here. A little squiggly line means I'm going to break my train of thought here and go to something else. What is 1/3 times 3x? Yeah, there's several ways to approach this, and it just depends on you and your brain and how things make most sense to you. One way to approach it is to just say these 3's cancel. You have a 3 on the bottom in a denominator, and this 3x is like up in a numerator. You can also illustrate that by just writing 3x over 1, and then you have a fraction and a fraction, and then the 3's cancel, which leaves you with just what? 1x, or just x, right? That's one approach. Another approach would be to actually write it like that again, and use the fact that when you multiply two fractions, you go straight across. Right? What's 1 times 3x? 3x. And then on the bottom, what's 3 times 1? 3, right? And then the 3 over 3 becomes a 1, and so again, you're still left with an x. Either way, at the end of the day, you need to be able to get x out of that. Now, if you just are sitting there and you just look at it and you know 1/3 times 3x is just x, you don't have to write anything else down. I don't need all that. That's just to show you what's going on here. So back to the problem, okay? When I distribute that 1/3 through, it hits the 3x and becomes x. We just saw that, right? What about that 1/3 times -6? 1/3 times -6. I'm going to look at that the same way. I'm going to look at -6 as being -6 over 1. You can go a 3 into this and a 3 into that, or you can multiply straight across. Either way. Don't want to go straight across? What's -6 divided by 3? -2. Okay? So that second red arc multiplication through is going to give me -2. Are my parentheses gone on the left? Yes. So I have equal sign, 2x. And now let's distribute that -1 through on the right side. -1 times x, -x. And -1 times +2, -2. I have removed grouping symbols. Do I have any fractions or decimals? No. Next step, collect all like terms together on left and right. On the left side, I can't do anything. On the right side, can you put anything together? Yes. 2x minus x, right? 2x minus x is x, and then -2. Now isolate your x. You have x's on both sides. So let's get rid of the x on the right. Subtract x, right? Whatever I do to one side, I do to the other. But you notice what happens again? See it? X's cancel, don't they? But this time, you don't say, oh, okay, as soon as the x's cancel, no solution. You don't say that. You look at what's left. What's left? -2 equals -2. Is that true? Yes, that's true, right? It wasn't like the last problem where we got some number is equal to some other number. These two are true. What that says is that in order for that equation to be true, all that needs to be true is that -2 equals -2, which it is, right? Which means that that equation is always true, which means that no matter what number you ever plug in, it will always work. Now, we're not going to start plugging numbers in because we don't have an infinite amount of time, do we? Right? Let's start with 1, then 2, then 3. I mean, we could check forever until the day you die. Every number you try will work. But this tells us that without having to do anything else. So I need to somehow be able to express that any number works. And so the way I do that is as follows. My answer would look like this. I could write all real numbers Have y'all seen that before, all real numbers? Why do we put real numbers? Why don't we just say all numbers? Why do we say all real numbers? No, fractions are real numbers. Yeah, well, that's why I brought it up. The reason why is because there's other numbers that are called imaginary numbers or complex numbers. And so this says that only real numbers will work. And the numbers that you deal with in your life are real numbers. Okay, you very few of you will ever get into imaginary numbers. I mean, we'll talk about them in this class and in college algebra. It's not stuff that you normally deal with, right? You don't go to the bank and be like, I'd like to withdraw 30 imaginary units. You know, I mean, it's just not, you say $30, 30 is a real number, that makes sense to everyone, okay? So that's why that real is actually means something there. So you have to put it for your answer, all real numbers. Or another answer, which is a symbol, just like that zero with the line through it. The way you write all real numbers, a double struck capital R. Double struck means two lines on the R, and then capital R. That is all real numbers. Now the book writes it this way, and I don't require this, but if you check your answer in the back of the book and it says it has this, I want you to know what it means. That's what the book will have. And all this means is that the answers are the set of all x values such that your x's are an element of the real numbers. That's mathematical writing, and it's a little bit tedious. Alien, yeah. So I think for us, this is a little bit cleaner, but understand what it means that x can be any number and that equation's true. We okay? All right. How are we doing on time? We go to 1:45, right? 1:45. Yeah. All right, let's look at this one. Give you a minute to write that down. It's your favorite thing in the world. Word problem. So write it down and then we'll talk about it. Now before, everyone have it written pretty much? Before I get into this problem, I want to talk a little bit about word problems because people tend to not like word problems. Any of you who were here last semester knows that they built a new bridge over here. Did y'all know that? They built a new bridge. You can, instead of that one, there's only one way to get across to the other side. There's another bridge over here now. So the engineers that built that bridge, right, usually are pretty good at math, right? Engineers have to be good at math. But they're trying to build a bridge that goes from, one side to the other side like this, right? Here's your little bridge going across. Please don't be jealous of my drawing here. That's a bridge, okay? So there is a mathematical equation, formula, that tells the engineer how thick the beams need to be, okay, in order to span a certain, to be able to go across a certain distance. The further you go, you have to use a different material, or maybe you need 2 beams, or maybe 3. But there's actual math behind it. right? I mean, I think we all agree on that. There's math behind a lot of engineering. Now, if you just put an engineer in a room and you give them a math problem and say solve it, a lot of the engineers can do that. Give them a math problem. The challenge for the engineer is to take the situation, the real world situation. I need a bridge that goes across this distance, and be able to take everything into account and translate it into the math. Okay, take it from the real world situation into x's and equations and symbols and all that, and then solve the problem and get the answer. So word problems are necessary in the real world because we're trying to take what's around us, find an answer, and then use the math to find that answer. This problem here has very little to do with a real world situation. But what it does is it requires you to translate English language into math. 5 more than 2/3 of a number is equal to 3 plus 7/9 the number. Find the number. So there are some key things in this sentence that I'm going to point out, and hopefully you'll retain this. All right, so on a test you're not freaking out. 5. Let's start with the first word here. 5 sounds like a number, right? 5. I'm going to put 5 above it. 5 more than. What do you think more than means? Plus, right? More than. You're adding something. So plus. I'm going to see if I can construct the entire thing just by moving along with the words. 2/3. What's 2/3? It's a fraction, right? 2 divided by 3. 2/3 of a number. Okay, of a number, but it doesn't tell you what number, right? That's the number we're trying to find. So since we don't know it, it's our variable. So it's x. The question is, it's 2/3 x, but what's the operation between 2/3 and the x? Is it addition, subtraction, multiplication, division? What is it? Multiplication. Why? Well, the word of translates into multiplication. Okay, so if you say 2/3 of a number, it's 2/3 times that number. So I'll put a dot and then x. Now usually we don't write the dot. It's called implied multiplication, right? Whenever we write 2/3 x, that's really 2/3 times x, but we don't put the dot. But I want you to see that that of is a dot. So 5 more than, so plus 2/3 times x of a number is equal sign, right? So a lot of times you are not going to be given the equal. It'll just say is. Is the key word for an equal sign. Now if they say is equal, that's even better. But you should know that the is enough for you to be able to put an equal sign. Is equal to what? 3 plus, oh, that's a little too obvious, isn't it? 3 plus 7/9 the number. So I didn't put 7/9 of the number, did I? But read it that way. What if it said 7/9 of the number? Would that still be the same thing? Would it make sense that way? 7/9 of the number? So there is, again, an implied multiplication there. So I'm going to put times, then the number is x, right? I'm just putting the things above the words. So now below this, let me write this all down. 5 plus 2/3 times x equals 3 plus 7/9 x. And I'm going to read it one more time. 5 more than 2/3 of a number is equal to 3 plus 7/9 the number. Does that make sense? And now we get to solve it. This is a linear equation, right? It's the first one we've seen that has fractions that are not going to go away, which is why I'm giving you this example. So let's follow our process. First step was to get grouping symbols out of there. We don't have grouping symbols. The second step, clear fractions or decimals. We have them now. And we haven't done one like this, right? We've never had to clear a fraction. So let's talk about what it takes to clear a fraction. To clear a fraction, we multiply both sides by what's called the LCD. What does LCD stand for? Least common denominator. Does that ring a bell at all somewhere? No? Okay, well, we're going to go through what LCD is right now. So what we do first is we look at the equation. We realize we have fractions. Anytime we have fractions, that means we have denominators. So I'm going to highlight the two denominators that appear in my problem. The two denominators are 3 and 9. Now, what about this 5 out here? Does that 5 have a denominator? Well, it's not really, but there is, if you wanted to, you could write 5 over 1, couldn't you? And you could write that 3 over 1. But we never consider the 1 when we're trying to find LCD. We only consider denominators other than 1. So we won't even care about that, all right? Now, to find the LCD, my recommendation, if I were teaching this for the first time, which I'm not treating it that way because LCD is something you should have seen at some point. What you do is you write out the two numbers. I make a table. Now, if there were 3 denominators, you'd write down all 3 and make a table out of all 3. And then what you start doing is you start listing out multiples of each number. So this is 3 times 1, isn't it? What's 3 times 2? 6. 3 times 3, 9, 12, 15, and I keep going, right? And then I do the same thing for 9, all the multiples. 9 times 1 is 9, 9 times 2, 18, 27, 36, 45, dot, dot, dot. What we're looking for is the smallest number, that's where least comes from, least, the smallest number that is common to both lists. So look at your two lists of numbers. What is the smallest number that appears in both lists? 9. Now, if we had 3 lists, it would have to be common to all 3 lists. Smallest number common to both lists here. So our LCD is 9. Is 9. Now, what am I supposed to do with that 9 to clear the fractions? We multiply both sides by that number, by 9. So let me do that below. Here's the way I'm going to do it. 5 plus 2/3 x equals, I'm going to leave a little space here in the front, 3 plus 7/9 x. I'm supposed to multiply both sides of this equation by 9. And since I'm going to multiply the entire side, I have to put the entire side in parentheses. Same thing on the right, and put a 9 in front and a 9 in front. So the black here is my LCD being multiplied on both sides. If you forget the parentheses, then you'll probably forget to distribute, and then things are going to be wrong. Are you all ready to distribute? Questions? I'm going to multiply the 9 times the 5, and then the 9 times the 2/3 x. I'm going to go 9 times 3, and 9 times 7/9 x. So I have 4 multiplications to do here. What's 9 times 5? 45. Now, I just showed you how to do multiplication of fractions, didn't I? And I understand that might be a hang-up for some of you, but I'm not going to go through all the detail and show it again. I'm just going to write down what 9 times 2/3 x should be. And if you are confused on that, just make a little note and then make sure you work it out with me or a tutor just so you're clear on it. Someone tell me what the next thing should be, though. The next multiplication. What's 9 times 2/3 x? 6x. Positive? Yes. Positive 6x. Equals 9 times 3? 27. And then 7x. Plus? Okay. And then at this point, we have no fractions. And that's the whole point of doing clearing fractions, is that when you're done multiplying by the LCD, you should no longer have a fraction. So we move on. We collect like terms on each side. Don't have anything to collect. We would now isolate the x term. So how would you isolate x here? You could do minus 6x on both sides. That would move your x's to the right, wouldn't it? So I'll go ahead and do that now. That would give me 45 equals 27 plus x, because 7x minus 6x is x. And then finally, to get that x by itself, subtract 27 on both sides. On the right side, you get x. On the left side, what is that? 18? And we're done. We never had to come through and divide. The number in front of x was a 1, so we never had to come through and divide by a number. All right, y'all hanging in there? We got one more example and we're done, okay? One more. What have we not seen? Decimals, okay? Decimals. Go ahead and jot that down. All right, so look, here's the thing about decimals. Whenever you have a decimal point, if you want to move the decimal point to the right one spot, what do you multiply by? 10. You want to move it 2 spots, multiply by 100. 3, 1,000, and so on and so forth. So when you have a problem that has decimals like this one does, by the way, we didn't have any grouping symbols, right? Then what we do is we want to make all of those integers. In other words, we want to make it where the decimal point is moved to the right so that there's nothing past it except zeros. So on the first number, 1.2x, if I move it one place to the right, it'll be a 12, right? And I'd be happy. But on the next number, 0.66, if I move it one, I would have 6.6, wouldn't I? So I'd need to move it 2 to become a 66. So I'm going to need to move it 2 places. Do y'all see that? Okay, on this one, 0.3, I need to move it 1 spot. So what would happen if I move it 2? It'd be 30 instead of 3. So that's okay. I'm going to have to move it at least 2 because of the 0.66. How about the 1.14? I need to move it 2 to become 114. So the most that I ever have to move a decimal in this entire problem is 2 spots, which means I'd multiply both sides by 100. Now, I don't like to come in there and write 100 in there. I just like to grab the decimal and move it 2 spots on every one of them. So that's what I'll do. I'm going to grab the decimal here and move it 2 spots. Now, that means the first spot, it becomes a 12. The next time, it becomes a what? 120. And then what about the x? It's just 120x. And then minus, now on the 0.66, move it 2 places and it becomes 66 equals, now on the next one, take that point and then move it 2 spots so it'll become a 30x. And then on the 1.14, move it 2 spots, it becomes 114. And at this point, you know, we've done enough of these, I think, now, right? Dot, 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 dot. So I'm just going to let it be for you. Questions? I'm not going to finish it out. The answer, though, is 2. Okay, so if you work this out on your own at home, you should get 2 here. Here's what you should do for homework. This is a pretty big assignment. It's somewhere around 20 problems. And from going off of what I did in class here, walking around, it was taking some of you about 10, 15 minutes to do a problem correctly. So this could be a pretty long assignment, but I think it's a good starting place. If you can do these problems, you know, you're in good shape. I anticipate you may have questions on this next class. That's fine. What I'm asking is that you get an honest attempt at this, all right, for next class. The answers to these problems are in the back of the book, so you can check to see if you got the right answer. You could always check by plugging in, but if you want a quick way, do it that way. Now, a couple of things before we adjourn for the day. You should try and keep your notes and your homework in two different places, because you know you're supposed to expect quizzes in here, right? Most likely when you come in here on Tuesday, there will be a quiz. And most likely, I'm going to say you're allowed to use your homework. But if your homework and your notes are mixed together, you won't be able to use anything. Or sometimes I'll say you can use your notes but not your homework. So keep them separated. And you know, I hate to do that because a lot of people like to keep things all in one place. But if you want that opportunity to use your homework, then you're going to have to keep it separated. The other thing I wanted to ask you is just how I told you we were going to do Tuesday and today with this sort of approach. So far, how do y'all feel? I'm just looking for honest feedback. Would you like me next week to go and try just the traditional board or not? If you don't want to tell me right now, you can shoot me an email if you have a strong opinion one way or the other. Just send me an email. Right now, I guess this is okay. No one's strongly objecting to this. Okay, then I'll stick with this and we'll just see how it goes. All right? It should be 2. All right, everyone. Have a good weekend. Be safe. Stay warm. I don't collect homework. Yeah, I don't collect homework, but I will go around and check it.
So I could probably do it in a journal.
Do it, yeah, wherever you want. And then usually what I'll do is I'll come and do a homework check. And I'm just looking for like, okay, yeah, it looks like you worked through the problems. If it just has all the answers, you know, I mean, yeah. Well, you know that, but not everyone kind of believes the same thing. So, anyone else need to sign in? You can sign in.